the next thing we're going to go over is profit has critical points when marginal revenue equals marginal cost, which is important for us to know because what are we always trying to do in business? Maximize profit. The profit is going to equal the revenue minus the cost. And whenever I want to maximize or minimize something, what do? I have to take the derivative and set it equal to 0. So I have profit prime is equal to revenue prime minus cost prime. I can just take the derivative of everything, and I would have marginal. Marginal means the derivative. It means if I increase something by 1, how much does this other thing change? Which is basically what we're doing with derivatives. Now we're going to call marginal revenue MR. We're going to call marginal cost MC. Now we have the derivative of the profit is equal to MR minus MC. If we go to find the critical points, we have to set the derivative equal to 0. If I do that, I get 0 equals marginal revenue minus 0. And if I solve that equation, I get marginal revenue equals marginal cost. And that's where the critical point is, which means that's where there's either a maximum or a minimum, or there could be nothing. We've talked about this. This is really important. We won't have to worry about looking for critical points where the profit is undefined. But remember that not all critical points are local max. The place where the marginal revenue equals a marginal cost could represent a local max, local min, or neither one. This is what we keep saying over and over. We're finding the critical points, but we have to make sure that we're finding the maximum or the minimum depending on what we're looking for. Example 4. A company sells Q ribbon winders per year at P dollars per ribbon winder. Important. The demand function for ribbon winders, again, important. P equals 300 minus 0.02 Q. The ribbon winders cost $30 a piece to manufacture, but there are fixed costs of $9,000, so they cost $30 a piece, and there are fixed costs of $9,000 per year. Now, find the quantity where profit is maximized. How do I find profit? Profit is equal to revenue minus cost. Let's start there. Revenue is equal to P times Q, where P is the demand function as given. Here we have revenue is equal to 300 minus 0.02 Q times Q. I need to know what my cost is. My cost is going to be equal to, so the quantity is how many? If I make 1, $30. If I make 2, $60. I just multiply those two. So I have a fixed cost of $9,000 per year. So if I make 1 ribbon winder, that means the cost is $9,030. But the more ribbon winders I make, the less each one costs because each one is taking a piece of that fixed cost. Now we can find the profit. So the profit is going to equal revenue, which is 300 minus 0.02 Q times Q minus 30Q. Don't forget to put this in parentheses because that might plus 9,000 is going to turn into a negative. This is equal to 300Q minus 0.02 Q squared minus 30Q minus 9,000. Let's combine like terms and put it in standard form, which gives me negative 0.02 Q squared. 300Q minus 30Q is plus 270Q minus 9,000. That is my profit. I want to find where profit is maximized. That means I have to take the derivative. So I have profit prime is equal to negative 0.04 Q plus 270, and minus 9,000 goes away because it's a constant. To find my critical point, I have to set profit prime equal to 0. I have 0 equals negative 0.04 Q plus 270. I have 0.04 Q is equal to 270. Q is equal to 270 divided by 0.04, which is equal to 6,750. I always read the question last. Find the quantity where profit is maximized. We did it. The quantity where profit is maximized is 6,750. So we get Q equals 6,750. This is our critical point. We still have to figure out if this is a maximum or a minimum, or neither. I can just take, this is so profit is a pretty easy thing to take the second derivative of, isn't it? So I can take the derivative of profit, which gives me minus 0.04, which means it's negative, which means it's concave down. And since it's concave down, it'll look like this, and I will have a maximum point. And that really is, for me, the easiest way. If I were to put it on a number line, I would have to say this is 6,750, and then I could plug in a number less than and see what happens. It should be positive. So let's go back to our derivative of our profit. So when Q is 0, it's definitely positive. When Q is 10,000, when Q is 10,000, we would have negative 400 plus 270, which would be negative. So again, we would be increasing then decreasing.